Good morning for all, and you are welcome to our TikTok webinar. Today we will have Professor Dردشة to speak about AI and machine learning. And first I will introduce Professor Dردشة. Dردشة is from he's co-director of Institute of Security Science and Technology in Imperial College in London. Professor Dردشة has intensive experience of leading STEM programs and initiatives in academia. Welcome, Professor. Professor.
Yes. Good morning, everybody. I guess we should start.
Yes, Professor. Professor, we'll start this session by your presentation. You have the floor for 45 minutes to present your presentation, and then we'll open for Q&A. I will read the Q&A for you, so you can answer.
That's perfect. It's great to be with you all this morning. So would you like me to start now? I guess you can see my screen. Is that okay? Is that working?
Yeah. Yes. So.
Okay. Perfect. So we'll start, and then in 45 minutes we'll do the Q&A. Okay. Well, good morning, everybody. So over the next 45 minutes, I'm hoping to talk to you a little bit about AI and machine learning, but in particular the challenges in developing this technology and the challenges in implementation. We're not going to do a particularly technical talk this morning, so it's hopefully something which a wide range of people can actually sort of couple into and understand. But we will start off with a little bit of a description of what machine learning and AI actually is. And I'd like to do that so that we could then understand, everybody gets an understanding of exactly what the challenges in development and implementation are that I will cover later on in the talk. So if you are very familiar with AI and machine learning, please forgive some of the introductory material. If you don't know any AI and machine learning at all, then hopefully the beginning of the talk will act as a good primer for you, not just for this talk, but for any other interactions that you might have with the subject matter in the future. So first of all, let's start with demystifying some language. We hear a lot about artificial intelligence, machine learning, deep learning. All of these phrases are on the airwaves the whole time these days. But it's interesting to step back and just understand a little bit about what the differences are. So if we look at a timeline, this is a graphic actually produced by NVIDIA, the graphics and processor company. If you look at the timeline from the 1950s to present day, we can see that in the 1950s, this topic of artificial intelligence sort of really took hold. And there was a lot of initial excitement about the ability or the potential for making computers intelligent in the same way as we see human beings as being intelligent. And people started working on ideas and concepts of how that might be achieved. One of the routes to achieving artificial intelligence, a method or set of methods that was then introduced to try and get to artificial intelligence, was machine learning. And we start really seeing a lot of work in machine learning, a specific way of achieving artificial intelligence. I suppose in the 1980s onwards, we see a lot of activity happening in machine learning. And then fast forward into the 2010s and onwards, a very specific implementation of machine learning as a set of techniques called deep learning. And so you can see that deep learning kind of fits into machine learning, which fits into this bigger goal, this bigger area of artificial intelligence research. So what is so different about machine learning and AI? Well, let's look at how we conventionally program computers and then figure out what's so different about AI and machine learning. So in the field of artificial intelligence, or AI for short, what we do is we program computers implicitly rather than explicitly. And by the way, for the rest of this talk, if I say AI, I will use that as a short form to mean AI or machine learning. So please forgive the fact that I'll just use AI and machine learning interchangeably. But now you know some of the definitions and the differences. Hopefully there won't be any confusion. So in explicit programming, which is what we typically would do if we weren't doing a machine learning type of programming, we would turn a mathematical formula into a series of instructions that a computer can use to undertake calculations. So here on this slide, we can see a formula that you all recognize. Speed equals distance over time. Everyone will have come across something like this before. And a way of calculating the speed of an object given an input of distance and time. So we know the distance and the time, we can calculate speed through this piece of physics, which, through human observation, through our observation of the world around us, human beings have divined that this is actually a piece of physics that holds for moving bodies. We can write this formula down, and then from this formula, we can calculate speed. We can then program this formula into a computer explicitly and give it lots and lots of distance and time information, and it can churn out lots and lots of speed calculations. So we would call that an explicitly programmed algorithm, or explicitly programmed piece of code in a computer. And important here to see that the intelligence, if you like, is supplied by the human being. In artificial intelligence, our goal is for the machine to learn that relationship. So imagine that speed equals distance over time relationship. We're looking for the machine to learn that relationship on its own. So whereas in the previous example, the human being had learned the relationship from looking at data and had written the formula down, imagine that we don't have an understanding of the formula, but we effectively want to expose the machine to lots of distance over time data, and for the machine to come up with that speed equals distance time over time relationship on its own. So the machine arrives at an understanding of the relationship through experience by looking at the data. And in this way, we say that this is an indirect or implicit way of programming the computer, because we never formally give it the formula. It learns that relationship through the data. And this process is what we call machine learning or artificial intelligence. And it's similar, but not exactly the same, as how our brains work, because obviously what we're doing here is through experience and observation, we are divining a relationship between speed equals distance over time, and we're trying to emulate that same process by giving the machine information and data and getting it to find out that relationship. But exactly how does it do that? Well, we create these structures called artificial neural networks, or ANNs, and they are the kind of building blocks, if you like, for building any machine learning or AI program that we might come across today. So I'm going to cover a little bit about what these actually are in a minute. Before I do that, it's important, let's just go back to this idea of giving a machine data. So we've given a very simple example there with the speed equals distance over time formula. However, we have to look at other more subtle problems, I suppose. So here is an interesting problem where a few decades ago, this data set was created. So these are numbers written down in handwriting from 0 to 9, and you can see variations in these various numbers. This is called the MNIST data set. And what we really wanted to do when we look at artificial intelligence is get a computer to undertake the kinds of tasks that human beings find very easy to do, but which for classic computing is very difficult. So the formula example that I just went through is fairly straightforward for a computer to do. It's a numeric calculation. But in this problem, what we're asking a computer to do is to recognize correctly and categorize all of these numbers just by inspection. So the job here would be to go through all of these different handwritten numbers and correctly identify a 0 or a 3 or a 5 or a 7 or an 8 or a 9. Now, for a human being, this is a very easy task, and for a computer, this has been a very challenging task in the past. And these are the kinds of games or data games that have been used to test whether or not we have moved further than just getting computers to do numerical calculations to something close to human intelligence. And a short time ago, this character recognition problem was considered to be a big challenge. And we've come a long way because this problem is now actually quite easily solved by the latest evolutions in deep learning and machine learning of the last sort of decade or so. So let's go back to this idea of artificial neural networks, and let's try and inspect exactly what an artificial neural network is and how it was inspired by the human brain. So what you're looking at here is a human, well, it's a diagram of a neuron, a biological neuron. And in a biological neuron, if you can imagine that on the left-hand side, what happens is we have these kind of antenna structures on the left of your screen called dendrites. And what they do is they collect electrical signals, okay? And then those electrical signals are gathered, some way added together, and then passed along the long central blue section that you can see to the other antenna structures on the right, the smaller ones on the right. And that's called, the long structure there is called the axon. And then we end up with these synaptic terminals on the right-hand side. The idea of the neuron is to take signals from the left-hand side, gather them up, add them together in some way, and then maybe fire a signal over in the synapses. Okay, and that's an important thing to remember when we get through to the next section. So if we take many of these neurons and we put them together end to end, what can happen is, hopefully you can see that what can happen is we can have signals transmitted from the neurons. They go through along those long axon structures that I mentioned a second ago. And at the terminals on the right-hand side of each neuron, we might get an electrical signal depending on what the dendrites had managed to gather. And if there's an electrical signal at the end in the terminals, then they might trigger another set of dendrites in another neuron, and so on and so on. And we would end up with signals propagating through this network of neurons. And this effectively, very, very simplistically, is how a brain structure works, a biological brain structure works, made up of these multiple neurons that are able to gather signal and pass signal on. So in the early days, trying to figure out how to create an artificial brain, if you like, using computing systems, the idea of an artificial neuron was created. And here we have an artificial neuron. And on the left-hand side, the big I stands for input. And on the right-hand side, the big O stands for output. And what we would do with an artificial neuron then is simply take in a series of inputs on the left-hand side, do something mathematical in the middle, in the big circle. And depending on that mathematical operation, there might be an output on the right-hand side. So you can see that we are now just trying to mimic, in a very simplistic way, the biological neuron that I showed you a minute ago. And then the idea is very similar again with the biological system. In an analogy to the biological system, if we take many of these neurons and we network them together, what we end up with is an artificial neural network. So here in this network, you can see an input layer. If you follow the layers from left to right, signals come in, some information or data comes in from the left-hand side, and then you can see in each of these neurons there are potentially 3 different outputs on the right-hand side of each neuron. And effectively what happens here in this artificial neural network, that signals can propagate right the way through the network, or data, if you can think about it that way, can propagate right the way through the network. And there's some mathematics that needs to be done inside each one of the circles, inside the neuron itself. We won't go into that too much now, but hopefully you get an idea now about how we can create a data processing network out of these individual artificial neurons, and how we create, therefore, from that, an artificial neural network. So these are the building blocks, ANNs are the building blocks of our machine learning programs and agents that we build today. And there I showed you a very simple 3-layer system with some simple interconnections. And of course, we can create hugely complicated multiple layer systems. And these are, in fact, then what we call deep networks. Okay, these are deep ANNs with multiple connections and multiple layers. And this is just one example of how you could interconnect a series of different neurons in multiple layers, greater layers than 3. So remember, we showed you, I talked a little bit a second ago about that, the MNIST data set, and I explained a little bit about the fact that that's a bit like a game. Well, it's important when we think about AI and machine learning to think about various games that we've tested our various algorithms on, because as I said, games are a kind of way of us trying to emulate what human beings can do very well, but in the past, we found it very difficult to get computers to do the same thing. So with our MNIST data set, what we would do there is we would give the computer the input data of those various figures that we showed you, the 0 to 9 figures, ask it to guess exactly which ones were zeros and ones and twos and threes, etc. And then when it would output its results, we would tell it how many it got right and how many it got wrong, and ask it to try again based on how we had managed to mark its results. And in this way, we would train the artificial neural network to learn how to correctly recognize the different numbers. The same sort of process could be applied to more complicated games like chess and checkers. And so in the early days, one of the things that was a big driving force around testing AI and machine learning algorithms was to see how well they could play complicated games such as chess. And this became a big sort of focus for research activity for a long time, to see whether or not we could get to the point where an artificial intelligence or a machine learning algorithm could beat a human player. This was a great way of testing machine learning algorithms against human beings, because remember, we're trying to see whether or not they can match that kind of human intelligence. So in the early 40s and 50s, a lot of work was done on this, and it carried on. There was a little bit of a winter when an obstacle was hit for a few decades, and it seemed that progress trying to create machine learning systems that could play these kind of games effectively was proving to be very, very difficult. And there was a time when people thought that potentially progress was going to stop there. But if we fast forward into the early 2000s, late 90s and early 2000s, advances in computing hardware, the internet, which made us created an availability for huge amounts of data, and various breakthroughs in algorithm design all came together in the early 2000s to really accelerate this field again. So much so that by 2017, this is a picture of a game called AlphaGo, and a 19-year-old master in 2017 was actually beaten for the first time in the game of Go, which is far more complicated than chess actually, was beaten by a machine learning algorithm. This is something obviously you can read about a bit, but this was a big breakthrough because it really showed and captured the public imagination of what machine learning and AI could actually achieve. So hopefully that's given you a bit of an idea on exactly how machine learning and AI kind of works. There's obviously a huge amount more detail that we can't go into right now, but at least it could give you a little bit of a flavor. I wanted to cover some of that because hopefully now you can see that because of the way a neural network is built, it's important to understand that we don't fully understand what the state of that neural network is once we have trained it. We don't fully understand how the computation is done. If you remember in the explicitly programmed example with my speed equals distance over time formula, I already know what the formula is, and I'm giving the formula to the computer, and it is simply just churning through the calculation. In a machine learning environment, what we're doing is we're exposing the machine to lots of data, and we are, through a process of iterative correction of the neural network, getting to the stage where the neural network is able to guess the outputs or to map the correct the data to the correct results. In this way, though, we lose sight of exactly what the structure is inside the neural network. And you just have to take my word for that for the moment. But effectively, what happens now is we're dealing with a bit of a black box, which means we get something which can compute for us, but we're not fully aware of how the internals of that machine learning agent actually work. And this leads on to big questions about how we fully explain how these systems actually work. And it also has implications on how we understand the trustworthiness of such systems during their operation. So if we have a machine learning agent undertaking a certain task, it's not fully clear exactly how trustworthy that machine learning agent is in executing the task under all sorts of conditions, particularly conditions that it may not have seen in the data before. And we'll get on to that a little bit as this talk progresses. So hopefully you've got a little bit of an idea now of what some of the challenges might be. And obviously, as I said, trying to explain what's going on inside that black box is a little bit is a challenge. And then it's also a challenge to understand also how a developer might have developed that machine learning algorithm if you're just a customer or you're using it, receiving it from a developer. However, let's pause for a second and look at what the massive implications are of AI and machine learning, and where AI is set to make a difference. Now, remember, in that speed equals distance over time example, that's a very simple example. But we have to think about scenarios where there's so much data and the systems are so complex that we're unable to pull out formulas, okay? And in very, very complex systems, as we find in finance and medicine, advanced manufacturing, marketing, news gathering and dissemination, all of the different topics that are listed on this slide, where it's not possible for us to create mathematical formula, but we want to be able to examine what the structures are that exist inside the data. This is where machine learning becomes extremely powerful, because we can give it huge amounts of data, and the machine itself, the artificial neural network itself, can actually discern and understand complex relationships inside the data that we cannot easily extract, as I said, as human beings. And this is the true kind of impact that machine learning is making on all of these different sectors that I've listed out in front of you. And the other, of course, areas where we'll see huge impact with AI and machine learning are on big global challenges. We talked about some industrial sectors there, but problems to do with how we could preserve the environment, how we can actually roll out medicine and health for the globe, how we can provide energy to the globe as well. The big global challenges around security and the building of data economies. These are all big, large-scale, multi-dimensional global problems. They're extremely difficult, but there's a lot of promise for how machine learning and AI can help us to sort of solve, address, and optimize each of these global challenge domains. However, let's switch on back to the challenges now. You get an idea of where the benefits might be, but what are some of the challenges now that we see in machine learning and AI? One of the big challenges is a large amount of misinformation and misunderstanding of the technology. And there's a lot of noise opinion about the current state and the potential of the technology, sometimes overhyped, some people would say, sometimes underplayed in some places. And there are a series of myths and valid concerns. I'm showing you a slide here, an excellent website called The Future of Life, and the link is on the bottom over there. And this is a group that is a group of researchers and people who work with AI machine learning, who are trying to carefully explain what the myths and the facts are about the challenges that we face. And there's a nice table here on the left-hand side. And you can see, just in the top of the table there, one of the myths, superintelligence by 2100 is inevitable. And the fact is it may happen in decades or centuries. We don't really know right now exactly when that's going to happen. That's the fact of it. Another interesting mythical worry is about, AI turning evil or AI turning conscious. Now, there's a big debate to be had around these kind of topics, but the real concern, and this is an important one, is whether or not we could develop machine learning agents, because actually what's happening with machine learning algorithms is we are trying to create automated systems that effectively just take data and make decisions for us. However, if we create automated systems out of these kind of AI and machine learning agents, we have to have some way of understanding that the way in which they solve problems are kind of aligned with our goals and our values. And this is a huge topic of interest at the moment, and it's a genuine concern. The divergence of the goals of AI and machine learning agents from our own over time is something that we do have to think about a little bit. Another thing to think about that we have to be very conscious of is the pathway that a machine learning agent might choose to reach a certain target or a goal. So for example, if you think about an autonomous vehicle being powered by a machine learning agent, if we simply say to the machine learning agent, you need to go from point A to point B as quickly as possible, but we neglect to tell the machine learning agent that it mustn't run over anyone while it goes from point A to point B, then of course it has multiple ways of getting to point A and point B, and it might choose to reach point B by actually harming people, which is something, of course, that we do not want to happen. So the point here is that there are multiple ways of achieving a goal, and we need to understand and be able to control the pathway that the machine learning algorithm might take to get to that goal. In this case, it's a physical goal, but there might be also data goals. And understanding that pathway and controlling that is very important for making sure that, again, the AI and machine learning agent is aligned to the kind of values that we have. And there's a whole series of other things there, which I will leave for you to read in your own time. So I'm wondering whether you'll be able to see this, but let's give this a go. So what we're seeing here is something called a deep fake, and this is another challenge that it's very important for us to understand. So a few years ago, researchers at Washington University created a synthetic Barack Obama. And what you're watching is a machine learning generated fake Barack Obama that is now being voiced by somebody else. So in this case now, as I said, what you've seen there is a fake generated Barack Obama. Machine learning algorithm has been used to analyze multiple images of Barack Obama and multiple videos of him giving speeches. And what's resulted there is a model which can be voiced by somebody else to generate a piece of footage which was actually never filmed. And of course, this is being able to handle this kind of misinformation, or what are called deep fakes, is something of a concern and a challenge when we look at the implementation and the use of machine learning and AI in society. Another important challenge is when we start looking at the interconnectivity of systems around the world. Machine learning agents and AI agents automatically making decisions in an interconnected world is something that we have to consider when we look at how computational systems and our systems, socio-technical systems of the world are becoming more and more interconnected. And there are cybersecurity risks obviously associated with this. And there is, of course, a potential here for machine learning systems to be used to attack in a cyber way, cyber physical systems around the world. What you're looking at here is a map of systems, actually of computing systems around the world that are in critical infrastructure systems. So these are computers that are controlling things like energy grids and water reprocessing plants. And this is a search that we did a little while ago. Actually was using a search engine called Shodan to see where there might be vulnerable systems around the world. And these are systems that might be vulnerable to cyber attack. Now, you can imagine a machine learning agent being given the task of automatically going and finding these and creating some sort of attack can have global ramifications. And again, this is an issue and a challenge that has to be managed and considered as we're looking at the implementation of such technologies. Now, another area which is worth considering is on bias. Now, remember I said that what we're doing is we're feeding machine learning algorithms data. And it's through this data, the data, if you like, is the fuel for AI and machine learning agents. But of course, all data is history if you think about it, right? Everything that's recorded has already happened. And when we start using machine learning and AI for subtle tasks, for example, in policing or in other applications such as that, using historical data may prove to be a big problem, particularly if we know that as human beings we have had biases. So, for example, if racial biases or gender biases, and if that data is fed into a machine learning algorithm and all it's going to do is learn from the data, then there's a very, very good chance that the biases that are already in the data will be manifest in the way that the machine learning algorithm or agent executes whatever the task is that we've given it. And here now we start realizing that just relying on the data and feeding the data to machine learning systems is not enough. And in fact, we have to start thinking about how we might be able to ascribe values to a machine learning algorithm as well as giving it data. So just think about the fact that a data set might actually have huge amounts of, let's say, gender bias in it. But our value may well be that we don't want to see any gender bias in the world or with the task that we're giving to this particular task. And of course, as I said, the value statement isn't borne out by the data. So if you just rely on the data, then you're going to reinforce gender bias. So there needs to be some way where we're realizing of ascribing values to these machine learning entities as some sort of value target, as well as giving it data. This leads to lots of other questions about which value system would you actually adopt? Will there be regional or global value systems? And who will decide and make policies about exactly what these values should be? And you can see that that starts becoming an extremely complicated series of questions to ask, particularly when we think about range of different countries around the world and the multinational environment that we live in. And remember, if you go back to the previous slide, we're living in a very more and more interconnected world. So the idea of having regional boundaries around such things is potentially a very limited one when we start looking about, when we actually examine how the world is actually changing at the moment. So if we do need policies and we do need to think about this a little bit, who is and isn't taking care of policy formulation? So this is a graph from the Library of Congress in the US, just quickly showing the various countries around the world, so a map of the world, sorry, with the various countries colored according to how sophisticated they are in their thinking around putting policies and regulations in place for AI and machine learning, addressing some of the issues that I've just outlined a second ago. So the blue countries on this graph have some strategy or a plan in place. And then we go down, you can see the key yourself from top to bottom, with some partial strategies right the way down to no strategy at all, actually in yellow, and then there are a series of countries which were not part of this study. But it's interesting to see where we have some strong strategies in blue, for example, in Canada, but also in China, and where we have some sort of weaker strategies in place as well. So in this particular chart, at this time, the picture has changed a little bit. The US didn't necessarily have a national policy or a national strategy. So one of the myths is, of course, that China, for example, has a kind of a very lax attitude to AI and machine learning, and anything goes. In fact, the opposite is true. China was one of the first countries to have a well-established strategy document in 2017, specifically talking about the generation of AI, and it has details and outlines, well, it has details that sort of outline the need for protection of privacy, talks about a sort of human-centric approach to the development of the technology. And there is a lot of referencing in this document and in this thinking around the global and societal impacts that AI and machine learning will bring. The thing that is concerning to some people, I suppose, is the fact that China has very clearly said that it has a strategy to be, by 2030, the recognized world leader in machine learning and AI technology. And it has a very clear 2020, 2025, and 2030 set of goals in order to get it to that final goal. The US position, I guess in 2020 up until 2019, there was no real cohesive position. In 2019, however, the government launched the American AI Initiative, and there's now been a lot of activity launching the AI.gov website and adoption of the OECD AI recommendations. So actually the formulation of some kind of national strategy and policy has only really taken place in earnest since about the beginning of 2019. And the approach adopted here, though, to date, has really lent towards industry self-regulation. And this is very, very important. So this is a much weaker set of centrally controlled, government-controlled policies and regulations to the one that we saw previously, really allowing the industry to self-regulate and to sort of enact best practice. Sorry. Then there's the EU position. And in 2018, the European Union produced an ethical charter on the use of artificial intelligence in judicial systems. And broadly speaking, the EU takes a position around respect for fundamental human rights, non-discrimination, quality and security, transparency, impartiality, and fairness, and the principle that the data and actions should be under the user control, whatever that means. So there is still some ambiguity here, but you can see the policymakers struggling or attempting to try and put these value statements into exactly how the technology should be developed and implemented, recognizing some of the risks that I talked about earlier on in this talk. And if we look at the OECD position, we see that there has been something like 40 countries have got together and established principles for the overall development of AI technologies. Again, this happened in 2019. And you can see statements here such as AI should benefit people and the planet by driving inclusive growth, sustainable development and well-being. AI systems should be designed in a way that respects the rule of law, human rights, democratic values and diversity, etc., etc. There should be transparency. They must function in a robust and secure way. Again, echoing some of the risks and issues and challenges that we talked about a little bit. You can see some of that being the UN convened the AI for Good Global Summit, which I believe is scheduled again to meet in September this year. And of course, the United Nations sets down a series of sustainable development goals. You can see them in the background here: good health and well-being, quality education, some of these value statements. So I'm just going to show you a few graphs here. Now, these graphs are interesting. They're based on data. Some of them are a bit old, but I think you'll get the point anyway. These were created by this organization, World Mapper. The idea here really is, does the data, when we measure what's happening in the world, does it really line up or align with these value systems or these values that we say that we're trying to achieve as humanity? So I'll just quickly run through this. This graph, dependent on the level of the magnitude of the measurement that we're looking at, the country is then dilated or made bigger in the following few graphs. Okay. So here, this is looking at global poverty, and we're looking at people living on $1.90 or less a day, and here you can see very, very quickly that we might want to be eliminating global poverty, but in fact we still have big problems with global poverty based in regions of the world. So if we wanted to create an equitable situation across the planet, if that's our value, which we see in some of the sustainable development goals, etc., we can see that we're not really doing very well on it when we start looking at data such as this. If we look at this next set of data, this is about water access in the world. Again, not necessarily doing a great job of that, although of course we would like to see water access for everybody in the world to be even. We'd like to see this graph looking, or this chart looking more like a normal map of the world, and seeing these massive dilations in the continent of Africa and around in the Asian subcontinent. But the data tells us something different. And this last chart actually shows the distribution of billionaires around the world, which shows dilations in quite a different set of countries and regions. So the point here is that the data that we currently have shows huge amounts of inequality around the world. And if we are going to use machine learning and AI to reinforce the point I made earlier, if we're going to use machine learning and AI to effectively try and solve some of those big global challenges, again, just relying on the data is probably just going to reinforce the current situation, if not make it worse. And so this goes back to the statement I made about putting values inside these systems. So I want to take a second as well, just to examine, we've talked a bit about governments and non-government organizations and how they're trying to think about guiding principles for the development and implementation of this technology. But let's look at the real players. And the real big players now, of course, are the technology multinationals. And here, just listing a few of the ones you'll be aware of anyway: Google and Tencent and Amazon and Baidu and Microsoft, and they are others. They really have a massive influence these days on whether or not regulation emerges or it doesn't. And in January 2019, Sundar Pichai from Google wrote an interesting op-ed in the FT calling for AI and regulation, wanting AI regulation and machine learning regulation. However, you have to look at whether or not asking for AI and machine learning regulation from a large corporate, you have to look at what the motivations might be for that, okay? And of course, there will be very good motivations for it. There's a genuine sense that potentially this area needs to be regulated. But there is also obviously the idea here also that for a large corporate, having AI and machine learning regulation can be a good barrier to entry for smaller companies and startups who are trying to get into the domain. Easier for a large corporate to adhere to regulation and to national policies than it might be for a smaller upstart company. So this could create an effective barrier to entry for companies or innovators who are perturbing the space of machine learning and AI. And we end up then with a question here on this slide, which is an open question, I guess, to you guys in the audience, which is how much control should these large multinationals have? And what's the balance of control between them, governments, citizens, etc.? It's a big open debate, I would argue, right now. And an example of where this debate came, we can see where the power of such multinationals came to the fore is, of course, you might recall a case a few years ago where after a terrorist incident, the FBI asked Apple to be able to unlock a mobile phone for somebody who they suspected was the perpetrator of the terrorist incident in the US. And of course, famously, Apple released a letter saying effectively that they would not cooperate with the FBI. And this was an example of a corporation being able to tell a government effectively that that they would not adhere to that kind of policy. And again, I'll leave it as an open debate as to whether or not that was a correct, incorrect decision to make. But it's just a nice example of exactly how the large corporates are able to kind of challenge the government and even then start looking at influencing how regulation goes, because of course at the time then this opened up a big debate about whether or not there should be regulation around encryption and whether or not governments should have backdoor access to encrypted data. And of course Apple then went one go further. This is an interesting graphic which was I think it was in 2019. It was at the Consumer Electronics Show where Apple had a big advert on the side of a building really talking about how privacy and encryption was their USP. And there's no accident that it was put right next to a kind of a stand for Google, who they view as having a slightly different view maybe cooperating with governments, etc., on security matters and allowing that kind of backdoor access. But as I said, this is just an example of the various debates and positioning that different corporates now have around exactly what their USP is and how they protect data, etc. And it obviously has a massive influence on how machine learning and AI systems will be rolled out in the future. And this moves on to something else here that I want to talk about very briefly before we end the talk. Now, remember, we talked about the fact that data is the oil here, if you like, or the fuel for machine learning and AI agents. And your data, your individual personal data, becomes something very, very important, right? Being able to pick up citizen data on all sorts of aspects of your life obviously becomes extremely valuable to these large multinationals, particularly when they're developing machine learning and AI automated systems. And this has obviously sparked a big debate around privacy and what privacy actually means. And I'm always interested in this concept of exactly what the data deal is now between individual citizens, the organizations that they actually interact with. That may be your workplace, it may be the place where you go shopping, and the government and the state. What exactly is the right deal here? How much information should you give to organizations and to your governments? How trustworthy are those interactions? And who should be in control of that data transaction? Now, people might say the individual should always be in control of that data, but then effectively, how do we build technologies to ensure that you as an individual have control over information, for example, health information on your physical health, maybe your relationships and debt, all of this data stuff that people, I think, have to be very conscious about and how they manage. Again, under certain circumstances, let's say in a security setting, does the government have the right to take priority and say, actually, we need this data and compel its citizens to give over that data? And that's a similar example to what I was mentioning a second ago with the Apple FBI case. All open questions at the moment. And there are some other big AI open questions. Going back to the beginning of the talk, how do we understand and audit the decisions that are made by a machine, by these machine learning agents? How do we instill values into these agents and ensure that they take safe pathways to solving the problems we give them? What could go wrong with the technology, and what would be the severity of any potential negative impacts if something did go wrong? Imagine a world with interconnected machine learning agents taking automated decisions. We could have global impacts for things that go wrong, and we have to be able to understand and be conscious of that as we roll out this technology in the coming decades. And what are the wider security implications of AI and machine learning in the world? We saw that example of deep fakes. Obviously, that's a video example, but of course, the ability to generate fake news and synthetic news and sway opinion right through social media channels and other media channels is something that's happening right now, and people are getting more and more sophisticated with that. So there are a number of these wider security implications that we have to be conscious of. And that leads us to a very big question around trustworthiness. And a question that people ask themselves all the time is, can we actually trust machines and machine learning systems? How can we trust them? But I would argue that this motivates a far deeper question, which is, do we really know what it means to trust each other as human beings first? Do we have metrics for that? And actually, it turns out, and I think that we don't actually understand that at all. And so the technology is effectively putting a mirror up to ourselves and asking us whether we fully understand what trust means. So the issue is not really whether or not we can trust the machines, is whether or not we actually understand what we mean by trust, and we can create some sort of framework or measurement around trust, which we can then use to actually create a trust mechanism or a framework for machine learning systems. And this is very interesting because it brings social science and the more technical sort of mathematical sciences very sort of creates a focal point for for all of these disciplines in order to answer this kind of question. And I want to finish with these big policy conundrums, because those are some of the technical conundrums, those are some of the technical problems that people are facing. But if you're a government or a state, you'll be concerned by some of these things, I suppose. Can we be confident that innovators understand how to progress their technologies in order to keep technology under control, and I've used parentheses there for under control, because do we even really understand what under control means? Have we defined that? And I would argue that we are still in the early days of actually trying to define that, as you saw with all of the different policy slides that I showed. If we regulate, though, as well, if we create harsh policies, could we hurt the economy and stifle the progress of these systems? That's something else you would worry about if you're a policymaker. And what are the legal status? What's the legal status of such AI agents? Because if they're going to be automatically executing tasks for us, and they're going to be learning from data in the way that I've just described, is it more effective to legally consider them almost as citizens rather than sort of bits of technology? And then this last big question around how we might control and inhibit the development of lethal AI weapon systems or laws, which is a big, real present concern. Hopefully you can see from what I've tried to describe, and something which people are thinking very carefully about right now. Post-COVID-19, given everything that's happening at the moment, we can see that there's going to be an increase in digital industry and government, what I call this sort of what's known as this sort of triple helix, in order to form policy making and push forward the technology development as well. And I think bringing together these different insights is extremely important, and will be more and more important in the coming years, because not one of these
I think there is some questions from Q&A. Let's start with the question from Ziana Alamki. Ziana, she's asking, what is the relation between analyzing data and AI and machine learning?
Sorry, could you repeat that again?
Ziana asking question, what is the relation between analyzing data, AI and machine learning?
Okay, great question. Yes, so I mean, I think what you've got to view, machine learning and AI algorithms or agents, I've used the words agents a lot. So when I say that, I just mean a kind of program, if you like, a machine learning or AI program. It's good to think about that as a data analyzer. In fact, what you are actually doing is you're putting data into it. And it is a way of us being able to extract information and insights from very big complex bits of data. So the relationship is very simple. Data goes in to these machine learning algorithms, and they rely on having lots of data in order to be able to learn in the way that I described earlier on. And so there's a very close relationship between data analysis. Well, not a close relationship. Machine learning is there effectively to analyze data. That's what it does.
Yes. There is also it seems like a comment from Ali.
Yes, sure.
Ali is saying that with all advancement in the last couple of years from deep learning in generating sophisticated generated content. Also, there is a question from an anonymous attendee. He's asking, what is the strategy toward AI and machine learning?
What is the strategy? I mean, I guess that's, I mean, I think what I'm trying to show in this talk, or just explain, is that actually there are a number of different strategies being employed all around the world. Yeah. And there isn't necessarily a single coherent view right now on exactly what the right strategy is. And so far, what you will see is that there are, I guess the strategies so far are very high level. They make very broad statements about, you know, machine learning and AI should sort of try and do good things and not hurt people, and you know, all that kind of stuff. But of course, the detail is what's needed a little bit now. And I think at the moment, there is a little bit of a lack of, there's a lack of understanding, I guess, of how much detail goes into those kind of policy statements or regulations. Because if you do too much, if you go too far and you put too much regulation and you put too many regulatory rules in place, etc., there is a chance, of course, that you could hurt the development of the technology because you do something which actually creates an obstacle, unnecessary obstacle. The other problem, of course, is that, you know, inside the policy making and regulatory environments, the government environments, if you like, it's not necessarily the case that there are enough people who understand how machine learning and AI works. Those people tend to be working inside technology companies, right? So that could be part of the problem as well, is that many people do not fully understand how this stuff works, and therefore creating detailed regulation and policy making around it can be a bit of a risk. And of course, look at the geopolitical situation at the moment. In order to create a shared set of standards across the world, you need an idea of political collaboration. And in many ways, what we see right now is some of those things breaking down a little bit, and people trying to go in slightly different directions. So yes, I think it's a big challenge that's playing out right now, and something that it will be interesting to see over the next few years how this all evolves. I hope that answers the question.
Yeah, thank you. Thank you. There's also a question from Sami Al-Belushi. He's asking where to start for beginner. What books can you advise, and can AI predict future events from previous data?
So on the first question, I think there are tons of places now where you can look to start. I would say actually, you know, the TensorFlow tutorials that Google puts together has put together are probably a very good start for people. It's quite interactive, and you can go and actually very quickly see how a machine learning kind of algorithm is put together, and how something like that is coded. I believe they used to have an example of the MNIST data set there. It's probably moved on a little bit from there now. But yes, I think that's a great place to go and have a little look. That's a resource which I think has been very well put together. I mean, there are a range of different books that you might look at. There's a particularly good book called Deep Learning by Goodfellow, Bengio, and Corville. I've got it in front of me right now. It's extremely detailed, actually. I'm not sure. I mean, if you were starting out, it would be perhaps a little bit challenging, but it's a great book to have as a kind of survey of the entire discipline. But I'd have a little look at the TensorFlow tutorials. I think they're good. They're very well put together. It can get you up to speed quite quickly. But you know, I should say, of course, as well, it's an extremely complicated topic, and machine learning and AI is, in fact, in my opinion, the amalgamation of a set of different technologies that have been developed for decades, and all of those components have been brought together. And it's actually rare, I think, to find even people who work in the field, to find people who understand all of those different elements together.
Great. Professor, that means it's better to search in the net and Google and other websites, or to read books?
No. There's no substitute for reading books. I'm a big bibliophile, so the textbooks are always finally the best place to go for the detail, I would say. However, the Google thing I mentioned, Google has as a method for building machine learning called TensorFlow. It's a kind of a programming environment. And they have tutorials on how to use TensorFlow. Yes. And those tutorials themselves, I think, are very nicely structured, actually. So they are well worth reading. And of course, if you've not done any programming before, you'd need to understand a little bit how to program. Python is a great language, I think, for people to begin programming in, and you can do some very powerful things with it as well. So learn some Python, maybe look at how to build something in TensorFlow, and then supplement with some textbooks. I mean, I can maybe make stuff available to you guys offline if the audience is interested, some reading materials and stuff like that.
Great. There's another question from Faisal. Faisal, he has two questions. First one, what topic should be studied to become creative in machine learning art? Mm-hmm. And another question, can you list them according to priority?
Okay, the topics. Okay, very interesting. Okay, listen, I think actually to be very effective with machine learning, you have to understand some mathematics. I mean, I studied physics myself, so I'm very biased when it comes to answering questions like this about physics. I mean, I think physics or some sort of numeric background is very, very important. Of course, computer science or something like that. But I think a good grounding in mathematics is very important to fully understand exactly what's happening in machine learning. And I would say, of course, within that, it'd be good to understand statistics, right? Because some people argue that in fact machine learning is effectively just a form of very advanced statistics, because you are looking at large sets of data and trying to pull out some sort of statistical significance from within it. And I think there's a lot to be said for that. So I would say that should be the #1 priority, irrespective of what you want to do with machine learning and AI. You must have some mathematical grounding, and it's not easy to maybe get those skills if you don't have them, but you must invest the time to do that. And then I think you'll get the most out of being able to be creative with machine learning and AI. It's very tempting at the moment for people to have almost no real grounding in that, because when you look at things like TensorFlow, it makes it very easy to create programs, machine learning programs, without fully understanding what's going on inside. That sort of black box thing I mentioned earlier on, that can take you quite far, but then you run into problems when you don't fully understand what's happening inside all of these systems. So I would say that that's the #1 thing. And I think, yeah, a good understanding of physics, I think, is pretty important too, because many of the times what you're trying to do is to use machine learning and AI to model natural systems. I mean, actually that's what you're doing most of the time, to model natural systems and understand natural processes. And so I think having some understanding of physics, mathematics is probably a very good grounding. And then of course you need programming skills. So you need a good understanding of how to do scientific computing. But then there are many tutorials around Python and things. I mean, I think Python for me is probably the best language to get into if you've never done anything like this before. And even if you continue for a long time afterwards, Python is becoming extremely powerful. It's fairly easy to learn, and it's a great language for AI and machine learning applications. There was a question around art, you said.
Yes.
I'm not sure I fully understand the question. Could they maybe expand it a little bit?
Yes. I don't know actually what is mean by art, but
I mean, one of the things I suppose I could maybe hazard a guess at what he's trying to drive at. I mean, I did some, when I was doing my PhD, I did a lot of work on image processing and the generation of synthetic imagery. And what you can do there is create some very artistic things just based on like the statistical properties of a scene that you're trying to create synthetically. So I think some sort of understanding, if you wanted to get into sort of the creative industries using machine learning and AI, if that's the question, there are some really interesting mathematical, people often think of maths and art as being two separate things, but in fact there are some very interesting mathematical kind of analyses of things that look aesthetic, if you like, that it's interesting to get into. And so you could look at various things, that images, for example, that look aesthetic, and they have certain forms and structures which are mathematical, which then allow you to start generating similar kind of forms synthetically, which could be pleasing to the eye or could be artistic. So I don't know if that's what the question was about, but there's hopefully that's of interest to the person asking the question.
Professor, I think there is a lot of questions.
I see that. I'm looking through all of them. Very interesting ones.
That's because of the timing. I think we have to close this session. Just if you have any final words to say.
No. I think it's been extremely interesting. Hopefully, it's been interesting for me to give the talk. I hope it's been interesting for everybody else. I see there are a lot of questions. There's one particular question on monopolization of data and what I think about that in the future. I think the topic around what I mentioned around bias, the monopolization of data, and the ability for us to go down the path where machine learning and AI only makes the current problems that we have of society worse, is a very, very important question to try and address. And I think people who are intelligent, who are thinking about these things, whatever the fields they are in, sociology or philosophy or science and political science, whatever it is, we should be thinking about this very carefully, because it's a moment in time where I think we have some important decisions to make as a society, and the technology is forcing us to look at ourselves. So,
okay. At the end, I would like to thank Professor David Channa from Imperial College London for his interesting topic and sessions. And I would like to thank him for joining us in this TikTok. And I hope all have had a nice time with us. Thank you, Professor.
Thank you very much. Thanks for the opportunity. It's been a pleasure. Bye-bye.